This video reviews the lesson on slope of a line. Rate of change is a ratio that describes on average how much one quantity changes with respect to a change in another quantity. And remember that a ratio is a fraction. So, if x is the independent variable, and remember independent is input, and y is the dependent variable, and the dependent variable is the output, then the rate of change is the change in y over the change in x. So it's change in output over input. So let's look at this example. We have the number of computer games and their total cost. So let's look at the rate of change between the total cost and the number of games. So first of all, the games is the input. It's the independent variable. It comes first. The number of games determines the total cost. Total cost is dependent on games. Total cost is the output. So let's look at the change in y, or the change in cost. So y goes from 78 to 156. So the change in y is 78. 156 minus 78 is equal to 78. The change in x, 4 minus 2, is 2. This ratio, this fraction, if I reduce it and simplify it now, is equal to 39 to 1. So $39 for every one game. It's $39 per one game. And I can verify it again by looking at this change in y. 234 minus 156 again is 78, and the 6 minus 4 again is 2. So once again, 78 divided by 2 is 39 over 1. So again, I get a rate of $39 to one game. Just notice here that the rate is staying constant. The rate is same for every change. Little FYI, this rate, it's constant. This rate is linear. Independent variable. Let's look at this rate. Let's look at the rate of change between the distance traveled here in this table and the time driving in hours. So once again, let's talk about input and output. The time driving determines the distance traveled. So the time driving we need to know first before we can figure out the distance that's traveled. The time driving is independent. It's the input. It determines the distance that's traveled. The distance is output. So let's figure out the change in y. So 492 minus 246 is equal to 246. Let's look at the change in x. That's 4. So the change in y, 246, over the change in x, 4. When we divide 246 by 4, we get 61.5. And again, let's do the labels. The change in y, it's miles per hour. We reduce that, so that's per 1 hour. Let's do it again and look at the next change in y. 615 minus 492. 615 minus 492, that's equal to 123. 10 minus 8, the change in x, that's 2. Change in y over change in x. When I simplify that, again, I get 61.5 miles per 1 hour. Notice again that these two rates are the same. They're constant. This rate is linear. Okay, so how does this rate of change, or this ratio that describes how one quantity changes with respect to another quantity, how does this pertain to lines? So if x is our independent variable, or the input, and y is the dependent variable, then the rate of change, the change in y is the rise over the run. Change in x is the run. So the rate of change with respect to a line is how a line rises with respect to its run, or how a line changes vertically with respect to its horizontal change. So if you look at this line rises 2 units and runs or moves horizontally by 3 units. This rate of change regarding a line is called the slope of a line, and slope uses the letter m as its alpha. So slope uses m, so the slope m of a line, the rise 2, here it is, the rise, over the run 3 is the slope of this line. Let's look at this line. If we read this line from left to right, just like we read English, you'll notice that we start here. This line is falling. So this line, the rise, or the change in y, or the vertical motion, is actually a drop, so it's negative. So the rise is negative, and if you look carefully at the units right here, this line drops 2 for every 1 horizontal unit. So the slope of this line, this falling line, is negative 2 over 1. So m is equal to negative 2. Let's discuss the classifications of lines. Lines are classified by their slopes. When you read a line from left to right, you'll see that this line right here starts here and then rises. This is a rising line and has a positive slope. This line over here, when you read this line from left to right, you hit this part of the line first. This line falls. A falling line has a negative slope. There are 2 more classifications, a horizontal line and a vertical line. A horizontal line, when you read from left to right, has 0 change to it. It's flat. There is 0 change to this line. So a horizontal line has a 0 slope. There is 0 rise, and you can pick any of these runs from point to point. I could go 1 or 3 for my run. This fraction 0 divided by 3 equals 0. A horizontal line has a zero slope, and an easy way to remember it is to go with the z's. Look at this vertical line. A vertical line, it has vertical change to it, a rise change. 1, 2, 3, 4. We could say 4. We can either go down with it or up with it, so it could be positive or negative for the change in y. But the change in x, there is no change in x. There's no movement for x. It's 0 in the denominator. Change in y over change in x. But now a fraction that has a 0 in the denominator is undefined. We cannot have a fraction with 0 in the denominator. Therefore, a vertical line has no slope. So you need to understand the difference between the two and get them straight. Horizontal lines, 0 slope. Vertical lines, no slope. Let's quickly review the classifications. A rising line here has a positive slope. A falling line here has a negative slope. A horizontal line has 0 slope, and a vertical line has no slope. Let's just go back to this falling line with negative slope classification. A negative slope is a negative fraction, and just notice the 3 different ways that you can write a negative fraction. With the negative sign in the numerator, or the negative sign written with the denominator, or the negative sign right smack dab in the middle. All 3 represent a negative value for the fraction. All 3 are exactly the same. So it doesn't matter how that negative slope is written. If you see it either way, they're all the same. And what this means is, look over here. The first one, down to, the negative sign is taken with the rise, positive 1. That's this first movement of the slope. The second one right here, this slope is saying we're going to go up positive 2 and then take the negative left on the number line, 1. But in either case, you go from this point to this point, and it's the exact same line. When you see a negative slope written like this, where the negative sign is in the middle, that just says you take the negative direction with the rise or the run, whichever one you want to take it with. So now let's talk about calculating the slope given 2 points. We said that the slope m is the rise over the run written as a fraction, or the change in y over the change in x, and change in means subtraction. So the change in the y values, you're going to subtract the y values, over the change in the x values means you're going to subtract the x values. So let's look here on the left, number 1. Let's read a line first for its slope. So down here on this graph, this line, as you read it from left to right, you hit this arrowhead first. So put your pencil on any one of these points. So I'm going to put my pencil right there, and I'm going to march from this point to the next point, and I must do the rise first over the run. So with my pencil on this first point, the rise is up 2, rise, then to the right 3. To the right 3 is a positive 3. So when I read this line, up 2 to the right 3, I read the line for a fraction of 2/3. Now let's go over to number 2 and let's calculate the slope. Now I calculate the slope by picking any 2 points on the line that I want. So I'm going to pick the ordered pair 5, 2 and 2, 0. I'm going to stack them for my calculation. So I line everything up, 2, 0. I'm going to stack them. And now I'm going to subtract. Remember, these are the x's and these are the y's. So my change in y is equal to 2 minus 0. Here are my y's over my change in x is equal to 5 minus 2. So 2 minus 0 is 2 over 5 minus 2 is 3. So I've calculated my slope, and of course they're the same because it's the same line. By stacking the ordered pairs, it just helps you keep the y values in line and the x values in line so you don't mix up your subtraction. Also notice your slope is positive, you have a rising line, everything matches up like it should. Let's look at this graph. First, let's read the line for the slope. So as we read this line from left to right, we're going to put a pencil on one of the first points that we hit. So we're going to put our pencil on this point first. And we're going to march from this point to one of the next points. And we have to march the rise first. Now in this case, the rise motion happens to be a drop. So it's a drop of 2, and a drop means negative. So a negative 2 over, let's take the run or the horizontal movement over 1 unit. So it's down 2 to the right 1. So we have a slope by reading our line of negative 2 over 1. Now let's calculate the slope. We calculate the slope by picking any 2 points on the line, and I've chosen to pick these 2 ordered pairs, negative 5, 4, and negative 2, negative 2, because I'm showing you that the 2 points don't have to be really near each other. So here we go. Let's stack them for our calculation. So negative 5, 4, and negative 2, negative 2. These are 2 points on the line. Here's negative 5, 4, and negative 2. Negative 2 is right there. So we're going to stack them, and I'm going to make a subtraction problem with these 2 ordered pairs. So change in y, or delta y, is equal to, now let's see, I'll show you again. Here are the x's and here are the y's. So delta y, 4 minus negative, to write the double negatives, over change in x is equal to negative 5 minus negative 2. So 4 minus a negative 2 is positive 6 over negative 5 minus a negative plus a positive. Well, that's going to give me negative 3 on the bottom. So this slope, 6 over negative 3, I get a slope of negative 2 or negative 2 over 1 when I calculate it. So both of the slopes are the same, as they should be, because the points lie on the same line. Whether I take 2 points close together or 2 points that are far apart, the slope will still reduce down to the same slope. And let's look again. This was a falling line, and the slope is negative, as it should be, because a falling line has a negative slope. Okay, so we have no pictures or graphs. Our job now is to calculate the slope without looking at any graph. So here we go. Find the slope of the straight line that passes through the 2 points -5, 2, and 9, -5. So kind of close your eyes, picture where these points are. -5, 2, that's in quadrant 2, and 9, -5, that's in quadrant 4. So to begin this calculation, we're going to stack our points. 9, -5. Make a subtraction problem out of them. Delta y is equal to, or change in y, 2 minus -5 over change in x is equal to -5 minus 9. So delta y, 2 minus -5, that's plus a positive. I'll get 7 over -5 minus 9, that's add the opposite, -14. Let's reduce the slope. We will get m is equal to -1/2. So now what kind of line is this if it's a negative slope? You're right, it's a falling line. Okay, let's do another one. Find the slope of the straight line that passes through the 2 points 1, 1, and 5, 1. So both those points are in quadrant 1. So to calculate the slope, we're going to stack our points, 5, 1, and subtract. So change in y, or delta y, is 1 minus 1 over change in x is equal to 1 minus 5. Well, 1 minus 1 for the change in y is 0 over 1 minus 5, at the opposite, is -4. 0 divided by -4 is 0. Remember our little jingle? When 0 comes out on top, it's the winner. So 0 divided by -4 is 0. A 0 slope is a horizontal line. So just want to keep that going in your mind. Whenever you get a slope of 0, it's a horizontal line. Okay, our last example. Find the slope of the straight line that passes through the 2 points 3, 4 and 3, 6. So we'll stack these 2 points to get set up to do an accurate calculation. I'm going to subtract. Delta y, or change in y, is 4 minus 6 over the change in x is equal to 3 minus 3. So 4 minus 6 is -2 over 3 minus 3 is 0. So now what's the story when you have a fraction with the 0 in the denominator? Fraction with the 0 in the denominator is undefined. So this slope calculation gave us an undefined fraction. So we have no slope here, or an undefined slope. So the slope is undefined or no slope, and also you should be thinking this is a vertical line. This concludes part 1 of our discussion on slope of a line.